to remind you that for more Microsoft webcasts, you can go to Microsoft.com/webcasts. Thanks again for joining us for today's presentation, 24 Hours of SQL Server 2008, Data Warehousing Management. Now it's my pleasure to introduce today's presenter, Bryan von Axelson. Bryan, you now have the floor.
Well, thank you very much, Alex, and welcome, everybody, as we continue with our 24 Hours of SQL Server 2008, continuing through our webcast series. We're going to build upon the webcast that we had on Monday as we took a look at data warehousing. We're going to take a look at how we can do some management of the data warehouse today. Some of the things we're going to look at are some of our minimal logging, taking a look at some of the partitions, backup. We'll see the agenda in just a moment. As we get started, I've already posted in the Q&A a couple things. The first one is a link out on the Microsoft.com site to go out and take a look at some of the things from SQL Server 2008. So I encourage you to take a look at that link, as well as posted my email. Those of you that might be joining us via the replay after we've recorded live today, that would be Bryan, B-R-Y-A-N, .von Axelson. So you can see it there on your screen, VONAXELSON at Microsoft.com. So again, Bryan.von at Microsoft.com. So let's go ahead and talk a little bit about what we're going to see today. So we're going to kind of focus in on some of the business intelligence features from the perspective as going through a fictitious company that we're going to call Contoso as they implement a data warehouse using SQL Server 2008. So some of the things that we're going to look at to make it easier to manage that data warehouse is we're first going to take a look at what's called minimal logging. Now, we could do some of this in SQL Server 2005, but we did have some limitations. So we'll talk about some of the comparisons between SQL Server 2005 and SQL Server 2008. But this is going to help us during that large data load as we may start working with staging tables in our data warehouse. Then we're going to take a look at managing. We talked a little bit on Monday as we took a look at, the idea of creating partitions. So here we're going to take a look at how we can manage those partitions and how we can add some new partitions and archive some old partitions. So actually doing some manipulating of the data within the SQL database into some of these different partitions. So we'll take a look at that as we try and manage our partitions. Then we're going to take a look at backup as we look at backup compression. Now remember, as we were talking about, with data warehouse management, we're talking about, having storage space. We need to start looking at how we're going to protect that data. So we're going to look at that from the backup perspective using backup with compression. So that's a new feature in SQL Server 2008. And then finally, we're going to take a look at one of my favorite new features in SQL Server 2008, and that is the resource governor, so that we can manage the different server resources, and we're going to do that from a workload perspective. So we'll go through a couple of demos that I have planned around each of these concepts. As we work through today's webcast, it's always helpful to have some preliminary information. So if you have worked with some of the previous versions of SQL Server, whether that's SQL 7, 2000, SQL 2005, it does help because we are going to be doing some things from a T-SQL, Transact SQL, as we look at some SQL Server queries. And then also we are working around the concept of data warehousing, so that does help. And we're going to kick off with a little bit of a review around some of the challenges we have from a data management process, and then we'll take a look at our first feature as we look at minimal logging. So let's go ahead and get started. So as we look at, in the previous session, we were talking about data warehouses, volumes. Some of the statistics that I threw out were that some of the warehouse volumes are actually tripling every 2 years. So that rapid growth in the data volumes does create some different challenges for us as the DBAs, as the IT professionals, maybe as the developers, as we look at how are we going to handle these challenges around data management. So first, we need to look at the data warehouse activity, and sometimes that involves a lot of inserts of new data into the dimension and fact tables. As a consequence, that does incur what's called heavy logging overhead. And a lot of times that really isn't necessary. Now, in SQL Server 2005, it did have a feature that lets you move data into an empty table with minimal logging. Now, it had to be an empty table. Now, this wasn't practical after the initial load of that historical data. If your data warehouse is tripling, every 2 years, then you're moving a lot of new data into those tables on a pretty regular basis. With so much logging happening, the total time required for the data load increased. You also ran the risk of filling up the available transaction log, the actual space for the transaction log, before the actual load finished. Also, one other challenge is partition. So we look at the organizations, and you've gone and you've implemented that partitioning. You want to manage these large tables more efficiently, but it is challenged to switch the partitions in and out. There's a couple different reasons around that. First, if an index view was created to speed up queries, the index views had to be dropped. Then you had to rebuild them when the partition switch was made. Second, the limitations of the date-time data actually cause a lot of pain for defining partition boundaries by both date and time when the natural partition was really only by date. Another problem caused by the increase in data volumes in the data warehouse is actually the space required to store backup. You typically need the same amount of space to store backup as the database itself requires. And sometimes I typically recommend you have multiple copies of your backups. So you do see that you need multiple exponentially growth of that space requirement. If you have multiple online backups, as well as having redundant backup copies, and then you're going to need that additional space. Also, you need some bandwidth to actually move those backups from server to server. Maybe you're going to move them out to another location that you're going to archive it to tape. So, as you look at the larger the database, the more time it takes to back up, the more time it takes to restore the database, the more time it takes to move those backup files. We also look at multiple workloads on a server. As we look at these multiple workloads on a server, they're going to compete for resources within the data warehouses. So the different organizations are supporting that 24/7 data warehouse. They can, typically not take the data warehouse offline for data loads and other maintenance activities. So these are the challenges that we're going to address today as we look at different solutions to tackle these challenges head on. So the first one is minimal logging. And as I mentioned, as we were talking about the challenge, in SQL Server 2005, you could get minimal logging under certain conditions, such as when using the bulk import or when using the select asterisk into, and you had your target from your staging, and the target table had to be empty. Okay, so that's the big difference. The target table had to be empty. In SQL Server 2008 now, you can use an insert statement to move directly into the target table from the staging without those same constraints. So as a result, instead of filling a page full of log records, you can now get a single log record for the insert transaction. This is obviously a great improvement for the data warehouse load scenario. If you also want to fully log and insert, you simply remove the with tab lock. So let me get my little highlighter here. So you simply just remove the with tab lock. That's what's going to make the difference there. And if you do without the with tab lock, you remove that out, then you're going to go ahead and move into that fully log, so that you'll get a log for each of the different records instead of just the page. So what are some of the requirements? Well, we need to make sure that the database is either using bulk log or a simple recovery model. We need to make sure that the target table is not being replicated, so it cannot be replicated. And then we need to make sure that table locking is specified. So you do need to specify table locking. So those are basically just the 3 minimal logging requirements. And this table here gives us a summary of the logging behavior of the inserts into a table when an index exists. When a table is empty, whether you use the tab lock, you can quickly see that whether an index is non-clustered or clustered. Minimal logging can only occur if the table is empty and you use the tab lock. One exception to this rule is when you have a non-clustered index, the table can be non-empty. In this case, you must use the tab lock, but the data will be minimally logged while the index will be fully logged. So good reference for you. Let's go ahead and take a peek at our minimal logging. So I'm going to jump into our first demo of the day. As Alex mentioned when we got started, if you hit F5, you will be able to maximize your screen during the demo, and then you can hit F5 again or hit the escape key. So as we set up the context for this demonstration, we can imagine that we are the DBA for Contoso. This company has implemented a data warehouse using SQL Server 2008. As we're working with the data warehouse environment, we see that we frequently have a high volume of new data to load, so we want to test this minimal logging feature that we've heard about as we look at changing some of the processes in our environment to implement it. So I've already opened up SQL Server 2008 and into the Management Studio. I got a couple of scripts in a project. So the first one we're going to do is we just want to start with a simple insert of data into an empty table. This table actually has no index and is currently empty. So let me go ahead and bring up my query here. So you can see here we're just going to insert DBO perspective buyer. You can see there I have the with tab lock. So let's go ahead and execute this script. When we come down here, we can see that we had 2,059 rows affected. So again, we basically just inserted into the table. So let's go out and read the log. And again, we did this with minimal logging. So here we need to check the log, and let's just see what we have. And notice down here we can see that that's 197 rows. And I could scroll down to the bottom, see that we are stopping at 197. So obviously 197 is a lot less than over 2,000. So we can verify here that we are using minimal logging. That did occur. Otherwise, we would see over 2,000 rows returned from this query. So let's do the exact same thing, just a little bit different. Now, instead of inserting it into an empty table, we're going to insert the data into a non-empty table that has no index. And so here's a little bit different table, again with the tab lock. Let's go ahead and execute this command. And again, you're going to see 2,059. So let's go ahead and do the same thing. We want to read the log. And you can see here 194. So again, we can see checking the log, 194 rows. That again tells us that minimal logging has occurred instead of over 2,000 records from full logging. Now remember, we couldn't do this type of minimal logging insert in SQL Server 2005 because the table had to be created by a select into statement. Here we actually did it with an existing table. Let's go ahead and return back to our slides. And while we do that, I'm going to close my solution. And we'll come back to our next demo in just a moment. So let's go ahead and start with a review. Rich recovery model supports minimal logging. And choose all that apply. There's actually two answers here. So you can actually use minimal logging with bulk logs or simple recovery models. The gotcha here is not with the full recovery model. So not with the full recovery model. So full is not the correct answer, as well as all of the above is not. So again, we can use minimal logging with the bulk log or simple recovery model for our database. And this one's pretty straightforward. Is it a prerequisite of minimal logging that a table is empty? Now remember, in 2005, we would have a different answer. In 2005, the answer is yes. In SQL Server 2008, the answer is no. You can load data into a non-index table as long as you use the with tab lock. Also, you can load data into a non-empty table that has a non-clustered index, but only the data will be minimally logged. So again, the correct answer for SQL Server 2008 is no. You can load data into a non-index table as long as you're using the with tab lock functionality. So let's go ahead and talk a little bit about partitioning. So as we review, partitioning is a technique that allows you to divide data into tables and indexes into smaller units. When your data is partitioned, you can load new data into the new data warehouse or perform database maintenance tasks more efficiently. I look at partitioning from a time basis. Ones that I like to set up typically have been a calendar year type process. So we're going to kind of work with some of that in our demo. And what we need to look at is over time, maybe we want to remove partitions, maybe we want to archive some of that unneeded data, maybe we want to add partitions to hold the new data. As we looked at managing the partitions and making some of those changes, what would I consider partition processing, that did present certain challenges with SQL Server 2005. So let's take a look at some of the things that we can do in SQL Server 2008. Starting with a fact table in our data warehouse that's partitioned by year. We want to set up an archive table that is also partitioned by year. The fact table contains data for years 2001 through 2003, and we've decided that we want to archive the data for year 2001. So the first thing we're going to do is go out and create a partition function that defines a boundary based on the first day of 2002. So we can see there we have a range right, and we have the values of 2002, 01, 01. This is going to give us a net result of two partitions. One partition for the dates earlier than January 1st, 2002, which effectively will be for the 2001 data, and one for dates greater than or equal, again the range right, to January 1st, 2002. So the next thing we want to do is create a partition scheme that's actually going to map the archive partitions to the same file groups used by the fact table partitions. Then we're going to go out and create the archive table. So you can see there where we say create table archive, using the partition scheme and defining the partitioning column. So now we've kind of got the preliminary information and the steps going, create the infrastructure. Now we're going to use the partition switching to move. So now we're actually moving the data. So we're going to use partition switching to move the 2001 data from the fact table into the archive table. The movement of the data is only logical, however. Really only the metadata for this partition changes, so that is defined as part of the archive table instead of the fact table, which makes it a very fast operation. And then lastly, we're going to do a merge to change the partition boundaries on the fact table such that the first partition no longer contains the 2001 data, but it only contains the 2002 data. As with the switch, the merge is simply a metadata operation. Now, the two most common partition column types are dates, using the date time data type in SQL Server 2005, and then some sort of identity column using an integer or big integer data type. Now, as we take a look at SQL Server 2005, if you're using integers as your partition column, then there's no problem. However, if the partition column uses a date time data type, problems can occur depending on how you set up your partition function. For example, you can set partition boundaries without any trouble if you choose to use the range right in your partition function, like we just saw in the previous slide. Now, if we're using a value like 2003-01-01, that's going to be extended to mean midnight on 2003-01-01. However, if you want to use range left, you can't use the same syntax because this leads to problems with partitioning in SQL Server 2005. Instead, you have to write your syntax like this to match the last time value in a day correctly, as we see there, 23, 59, 59, 997. The problem showed up specifically in what's considered a sliding window scenario, where you keep an extra empty partition at the end of the date range to make it easier to insert a new month by using the split operation. If you got this partition boundary wrong, you didn't have an empty partition, and then the partition switch that you thought was going to be a metadata-only operation actually turned into a data movement operation. So with SQL Server 2005, we do have the data type, which allows you to avoid handling time altogether. And you can more intuitively use either our range right or range left in our partition functions. Now, as we've also learned in the first session in the webcast, as we took a look at the data warehouse concepts on Monday, partition aligned index views are helpful for boosting query performance. As we looked at SQL Server 2005, index view was not aligned to a partition, which means you had to drop it before you could switch a partition, then you had to rebuild the index views after switching. That particular process tended to be slow. Queries that depended on the index view were also slow during the rebuild process. As we look at SQL Server 2008, when you create a partition-aligned index view, you can switch the partition and the index view switch occurs as well. So a common scenario for regular partition switching is, again, that sliding window archival process. As we take a look at that process, you would actually switch data from existing partition to an archive partition in another table. Now, that process is going to occur much faster than physically transferring the data from one table to another because, again, only the metadata actually changes. Then we can easily switch in new data without impacting the existing indexed views. Now, not only is this process greatly simplified because you don't have to drop and rebuild the indexed views, but the queries that depend on the index views won't be impacted either. So our net-net, you can more easily manage the sliding window archive process, as well as when we're working with our recovery time, it's going to be reduced because we can back up and restore individual partitions. So for our second demo, we're going to do just that. We're going to take a look at partition switching. So again, we're going to jump back into our virtual world. Excuse me there. Still been fighting this allergy season. So I'm going to go out and open up another solution as we take a look at our partition switching. So again, in this example, what we're going to do is we're finding that the most frequently accessed data and the most recent data and usefulness of the old data is dwindling over time. We expect to have very large tables. So we have heard about some of the usefulness and the ability to archive this old data from time to time to improve performance. So we also need to make some space available for some new data. So let's take a look at what we can do with SQL Server 2008 to perform some of those tasks. So currently, as we take a look, we have reseller sales fact table, and it's partitioned by year from 2001 through 2004. And what we decided to do is we want to archive the 2001 data, and we also need to make space for a partition to hold the 2004 data. So let's go ahead and bring up our first script. And the first thing we need to do is we need to create a partition function for the data that we want to archive. Again, the partition function defines how rows get mapped to specific partitions. As we take a look at this example, we're going to be using the same partitioning strategy as the fact table, which is the order date key. Now at this point, we don't name the column, however. Instead, we identify the value to use as a boundary for the partition. As we look here, we see range right in this statement tells SQL Server to use values greater than or equal to the value we supplied. And what value do we supply? Well, we're going to supply the January 1st, 2002. So again, we're going range right, and we're going to give it the value of January 1st, 2002. And with the range right, that actually represents the first day of 2002. So let's go ahead and run our script. The second thing we need to do is work with our partition scheme. And remember, the partition scheme maps the partitions to file groups. Because we are archiving only 1 year right now, we're going to map 2 file groups. 1 file group for the year of the archive 2001, and 1 file group to hold an empty partition for our future archive operations. So as we see here, we're going to create the partition scheme, and then we're working with the file groups of 2001 and 2002. So we'll go ahead and execute. And then we need to create the archive tables. We're basically going to call this the Fact Reseller Sales Archive, as we can see right here. So we're just going to create our table. Now, as we create this table, we also reference the partition scheme we created, provide the column name that contains the value to be used for partitioning. And again, in this example, it's the order date key. Go ahead and close that out. Now, before we move on to actually start switching the partition and we actually load the data into the archive table, let's see what's in the 2001 partition currently that we just created for the Fact Reseller Sales partition table. And we want to confirm what's going on with the archive table. So let's go ahead and see what do we currently have. So where are we at right now? So I'm going to pull this window up just a little bit so we can actually see, as we look at our 2001 data in the Fact Reseller Sales partition, we do have some information. We've got order date key, July, August, September, October, November. So we see a fair amount of 2001. And we look down here at the bottom, we have no data in the Fact Reseller Sales archive table, which is what we expected. Now we're going to come back to this one, so I'm going to leave this one open. So remember, we had data in the top, and that would be, the reseller sales of 2001. And then we look at the bottom window here, we have the Fact Reseller Sales archive. And as you can see, we have no data. So let's go ahead and keep moving through. The next step is to actually switch the first partition from the partition table to the first partition of the archive table. Now again, in actuality, no movement really occurs here because the change to partition is occurring in the metadata only. And now we want to look at merging the partitions. So now we're going to change the partition functions for the fact table by using the merge to remove the boundary between years 2001 and 2002, which is the order date key, again represented with 2002 01 01. So let me scroll over a little bit here. And again, now we have only 2 partitions in the fact table, one containing data for the year 2002 and the other containing data for the year 2003. So let's go ahead and execute. And then lastly, we're going to split. So we're going to add a boundary. Again, we're going to add a boundary to the partition function for the fact table To make space for adding 2004 data using the split, as we execute this statement, we're now going to have 3 partitions again for the fact table. The first 2 for years 2002 and 2003 contain data, and the third partition for 2004, which will be empty. We'll go ahead and execute. Now we want to go back as we've performed some of these switch operations, move data to the archive partition, and let's see what the difference is as we run that exact same query. And hopefully you're expecting what I'm expecting is the exact opposite of the results. So let's execute that. And as you see, right there in the reseller sales 2001, we have nothing. And now in the factory seller sales archive, we have all the 2001 information. So as we can see, the data shows up in the archive table. It was very quickly accomplished in our demo. So let's go ahead and review some of the concepts from our partition processing. So which of the following steps are not required before archiving a partition? So which of the following steps are not required before archiving a partition? And we've got several people coming in. Now they're starting to show up. Looks like the majority of you are going for the bottom one, and that has to do with dropping indexes. Remember, in SQL Server 2008, you no longer need to drop index views before switching out a partition. Even better, you don't need to rebuild the index views after the partition switch is complete. So again, in SQL Server 2005, this was one of the limitations. But in SQL Server 2008, you no longer need to drop the index views before switching out a partition. And what's even better is you don't even need to rebuild the index views because you didn't drop it. And then another review question here. Partition column must be a date time or data type. True or false? True or false? Well, we've got a good split going on here. About 75% of you going with false, 25% of you going with true. And the answer is false. You can use any data type, including data types for characters, but most commonly partitions are defined by a column that relates to date. This could be a date-time column, the new date data type that we're introducing in SQL Server 2008, or an integer data type if you're using a surrogate key. Two down, 2 to go. As we took a look at implementing our minimal logging and what we can do to manage our partitions. As we've talked about throughout the SQL Server webcast series, one of the things that we've talked about is, proper sizing of the SQL Server, and making sure that, as these data loads have increased over time, that we're expecting data warehouses to triple every 2 years. This definitely has an impact on our disaster recovery as well as the backup strategies. So we start to look at, if we have a large data warehouse, do we have a large data warehouse backup? And how much time does it actually take to perform that backup? Now, as I've mentioned in some of the other webcast series, typically what I like to do is actually run a backup to a hard drive set on the SQL Server, and then I will have that hard drive set on the SQL Server, either go out to another server in the environment or use that to get to tape. I also like to have multiple backups. The cost of disk space has typically been falling, but as we look at implementing data warehouse storage, we start to look at it does kind of offset that fall in disk space because our requirements are higher. We need more of the hard drive space because we're probably going to store a different number of backups, and we want to make sure that those are available online. We also want to make sure we have some redundant copies, and again, that was redundant copies, not just a redundant copy. Required, maybe we have an increased demand in overall storage. We also need to look at backup and restore operations. Tend to be I/O bound, so the time it takes to create the backup and to move that file, if we are going to move a different server, tends to exacerbate the problem as well. So one of the things we're going to talk about is backup compression, and that can deliver what we consider a significant space savings from some of the testing that we've done. We're looking at a 5-to-1 compression ratio. Now, of course, different types of data, will have an effect. So there's always that caveat, that great, computer answer. It depends. It depends on your type of data and your database. But you should see, some pretty good compression rates. What we're going to see in the example as we do the demo is, that 5-to-1. So, that's pretty good amounts of compression. If there's a lot of redundant data on the same page, we can actually get more compression as well. So the reduction in the size of the data through compression is going to give us what I consider less pressure on the I/O. That's going to translate to faster backup and restore operations. And then obviously, when restoring a compressed backup, you don't need to do anything special. The compressed state is automatically detected. The database is actually decompressed on the fly. Now, as we talked about in the previous SQL Server webcast, there's a cost. There's a price for the savings in disk and speed, and that is offset by CPU. So there is an offset for the savings in the disk and speed that more CPU is required. So this is definitely something to be aware of as we look at the plan of timing our backups accordingly. So let's take a look at a couple of notes, the things that we should realize about backup compression. One of the first things is that it's a SQL Server 2008 Enterprise Edition. However, you can restore a compressed backup to any edition of SQL Server 2008. So to compress the data during the backup, with the built-in, again, there's lots of third-party options out there as well. But to compress the data during the backup, you will need the SQL Server 2008 Enterprise Edition. But what's nice about that is you can restore a compressed backup to any edition of SQL Server 2008. Backup compression is turned off by default. Simply use the stored procedure, so sp_configure, to enable the backup compression on all backups. Or you can use another alternative, as we're going to see in our demos in just a moment. You can use the with compression clause in your backup statement to apply compression selectively by the database. A media set can contain either compressed or uncompressed backups, so you have to make a choice. So again, a media set can contain either compressed or uncompressed, not both. And if you're using data compression, you might see a significant decrease in the size of the backup. So again, if you're using data compression, you might not see a significant decrease in the size of the backup because the data is already compressed. So here's where we look at a trade-off. Are we compress? It's kind of like zipping a zip file. When you zip a zip file, you're not going to gain that much space. If we've already compressed the data, then we may not see significant changes in the size of the backup. So let's go ahead and take a look at our backup demo. So once again, I'm going to open up another solution around our backup. And we're basically going to run two different backups, one that is compressed and one that's not compressed. So again, as I pull up the statement here, we're going to see back up the database. We're going to send it out to the disk. Okay, we're going to use the compression, and we're actually going to get some stats on it as well. And then the other one is no compression. So the first one's with compression, second one, no compression. So let's go ahead and execute. It's going to take just a moment. So again, in the first statement, we're using the with clause backup statement to include the compression option. If you've not changed the default configuration of the server, you can omit this option because the backup compression, again, it's not enabled by default. So let's go ahead and see the difference here. We can see some of the different stats and information back. We can see that we were successful. So let me go ahead and close that one, and we'll actually pull up some of the information around our backups. So one of the things we can see is that the data plus the indexes, consuming some space here. You see the database size, 118, what's happening, reserved data. So as we come down here, notice, let me go ahead and hide this out so we can expand this a little bit. And the ones we want to key in on are those bottom two, backup compressed, backup uncompressed. So we can see elapsed time. We actually have a elapsed time on the uncompressed versus the compressed. Again, the database in our demonstration is not very large, so the difference in backup speeds, not incredibly different, but as this database were to grow, we would see a good distinction between our elapsed time here from our compressed to uncompressed. Backup size, again, back to that 75, 80 megabytes that we see. But notice here, we come over here and we actually see what is the size of the backup file. Again, makes sense here, uncompressed. Well, how big is the database? Well, it's set up for 120 or so. We've got almost 80 in the database. We're uncompressed it, so it's 80, the 78, which gives us a ratio of 1. Versus with the compressed, here we have 78, and again with the compression, the actual backup size is only 14, giving us just a little over 5-to-1 ratio. All right, let's go ahead and go back. We'll do a little bit more review as I bring up the review slide. Now I'm going to start up another virtual machine here for our last demo. So let me start that one up. While you take a look at a question of which of the following does not decrease when backup compression is enabled. So again, what does not decrease? That's what we're working our backup compression. Remember some of the things, the caveats that we had talked about. We're going to get better disk space. We just saw we can get some better backup time. The file's actually going to be smaller, so we should actually get better restore time. Not only does the CPU usage not decrease, it actually increases. That's the trade-off. So again, the CPU usage increases during backup compression. Now that impact is offset by the decrease in time spent to perform the backup as well as the restore operation, as well as the amount of space saved due to compression. So again here, the answer is CPU usage. It does not decrease. In actuality, it will increase. So true or false? Backup compression does not require data compression. True or false? So the answer is true. Backup compression does not require data compression in the database. In fact, backup compression is typically going to yield higher compression ratios when you don't compress the data first. So it does not require data compression within the database. This is only during the backup. However, you can back up a compressed database, but you probably won't see the same compression ratios because it's already compressed. So you won't get that 5-to-1 ratio. So let's move on to the last topic as we're closing in at the bottom of the hour. So as our data warehouse grows, we can expect the number of concurrent queries to increase as well. We need to start looking at how we can manage system resources, limit the impact of resource consumption, as we have different activities, what we're going to call workloads for our discussion today. As we go to manage these resources effectively, we're going to look at a way to establish and enforce thresholds for what we call resource utilization defined by a workload. As we introduce the resource governor in SQL Server 2008, that's the tool we're going to use to help achieve this goal. For each workload, we're going to define the thresholds for our CPU utilization as well as our memory use. And that's going to give us the ability to manage the resource consumption so we can prevent maybe a runaway query in one workload from adversely impacting the performance of another workload. Additionally, we can, besides setting the resource thresholds, we can establish relative priorities for each workload as far as the different importance. And then as we become proactive with our workload management, we can decide, what do we have for mission critical workloads, define those appropriately so that they have a consistently same experience. Maybe we're going to work with our SLAs, as well as working with maybe some co-hosted workloads, or we can divide some of our workloads as medium priority or low importance. Now, it is important to understand that the resource governor manages only the database engine. Resource governor cannot manage resources for some of the other services that bundle into SQL Server 2008. So I think of the services, I think of the big three, SSIS, which is SQL Server Integration Services. We think of analysis services and reporting services. So the resource governor manages only the database engine. So let's take a look at some of the concepts before we do our demo. When a new session connects to the server, classifier function executes. This is a T-SQL user-defined function. Takes no parameters, returns the name of a workload. As we explain the workload groups in a moment, the classifier function you create can be as simple or as complex as you like. You can use this function to check the host name, the application name, the username, even the time of day, as we take a couple examples. In our example, you're going to see me using the mission critical definition as well as the low importance definition. So my classifier function is going to be built into the scripts It's actually the same script. One's called mission critical and one's called low importance. The point is you want to find a way to differentiate between the different activities, whether those might be maintenance activities, user queries, so we have the ability to ensure the higher priority database activities get the resources they need. So the first thing we need to do is have a way to determine what that activity is, and that is actually the purpose of the classifier function. The incoming session has been assigned to a workload group. Now, there are actually two system-defined workload groups. We're going to see those in just a moment. The internal group and the default group. The internal group is for background tasks performed by the SQL Server. So you don't need to worry about some of the server activities. The default group is used when the classifier function cannot assign a workload group to the incoming session. So internal is internal to SQL Server. Default is, I'm not sure what group it is with the classifier function. You may have defined some, you may not have defined some. If it's, not sure, it's going to put it in the default group. As we look at working with the processes that we want to manage, again, we have the ability to create our own workload groups. And again, we're going to see this in the demo as I have created a low importance work group. So we kind of want to think of the workload group as a way to group together maybe users, reports, applications, batch processes, so some of the different things we might have happening in our environment. And then each workload group is bound to the resource pool. Again, the internal and default resource pools are system defined. You're not going to be able to change their settings. Again, the purpose of the resource pool is that's where we're placing the limits on the resource consumption of the workload groups. You can set up as many resource pools as you need, map the workload groups to each resource pool. You then assign minimum maximum thresholds for CPU as well as memory utilization for the respective resource pool. We can also prioritize workload groups within the resource pool. So let's go ahead and take a look at that in our next demo. So I'll pull up my SQL Server here. And one of the first things we want to do is I'm actually in the Management Studio. And the Resource Governor is part of the Management tab. So I'm going to expand out Management, and there we can see Resource Governor. As I start to break out the Resource Governor, here we see our resource pools. There I have the system resource pools. Again, those are the built-in. We have the default and the internal. And I also have the low importance pool. And underneath I have the low importance workload work group. If I wanted to create a new pool, I just tell it new resource pool. SQL webcast demo. We can actually tell it, okay, 25, maybe we're going to do 50, and we'll go 25, 50. We can also work with some of the different names for the workload groups, and here's where we have the ability to set low, medium, and high performance. So now as I break out my resource pools, here we can see the SQL webcast demo. At this point, I could actually create a new workload group. So you can do it either way when you create the pool or as you pull it up. And again, we'll go 25. Let's see, maximum. Let's do 50. So just some of the different things that we could do. So just to show you, let's pull up default. Notice as we pull it up, we can see the others as well. So we can actually scroll through them. So internal 0, 100, default 0, 100. Low importance, that's what we're going to do with the demo. So I want to pull that one up so we can show the numbers. So we have 0 on the minimum CPU, but we maxed it out at 10. Minimum on the memory, 0, and the maximum on the memory is also 10. So let's go ahead and click OK. So we've kind of seen how to create the workload groups and some of the resources, as well as I showed you the low importance workload group. So let's kind of see the end results after we've created it. So we're going to go out. I have 2 scripts. Let's first bring up the scripts and show them. The exact same script, but my classifier function here is how I'm naming it. So I have the low importance application, and I have the mission critical application. The exact same script, but the difference is the name. So let me pull up the performance monitor. Here, as I pull up the performance monitor, I'm just going to bring it out just a little bit for the desktop. So one of the things that we can look at here is that we have the defaults as well as the low importance pool. And what we're going out after is the CPU usage on the SQL Server. So yellow is for the default, remember, with the classifier functions. If it doesn't recognize what to put it in, it will put it in the default. Internal is just the internal SQL Server. And I do have another one that is defined as the low importance pool, and that is pink. So what I want to do is actually show you the first script running and show you my favorite feature about this is, remember, we had it governed. We have it governed at 10%. You're sitting there going, well, Bryan, I see that pink line spiking up and down. Yes, you do. Because if it's the only workload running in the SQL Server, the governor is not going to govern a straight line across. The resources are there. It's the only thing running, so we're not going to govern it. So it actually has some intelligence built into it. Now let me start the mission critical governor, and now we should see the yellow start to peak up. And we're actually going to see an inverse relationship. As we have the peaks of the yellow, which is again the default workload, we're going to see the pink drop down to that 10%. As you see everywhere that I have a peak, we have a couple over here. You know, we have it down into 10%. We have some extended peaks right here. Notice it's down 10%. But notice when the yellow dips, again, because it doesn't need the particular resources, it allows those resources in the pink area to have access to that. So again, it has the intelligence that if the resources are not being used by the particular workload groups, it frees it back up. So we actually see that inverse relationship. Great example of the resource governor. Let me switch back before I shut down my VPC. And we've got a couple of review questions on the resource governor. And then we'll wrap up today's webcast as we hit the bottom of the hour. So which of the following services can the resource governor manage? Oh, got a split going on. Again, remember what I said. The resource governor can only manage the database engine. It cannot govern the other services such as integrated services, analysis services, and reporting services. So the correct answer is the database engine, not all of the above. Okay, which of the following criteria can be used to define the classifier function? And the correct answer is all the above. All the above. All the above. All the above. You do have a great deal of flexibility when you define how the classifier function will assign each incoming session to a work group or workload group. So you can use time of day, you can use the username, you can use the database name. So again, this is working with that classifier function. And again, in my demo, I use that with the naming of low importance. So low importance is how I did it during the demo. Let's go ahead and wrap up today's session. Kind of hitting the 4 bullet points that we talked about. SQL Server 2008 is going to minimize the impact of high volume inserts as we bring in the bulk inserts, etc., on our transaction logs as we take advantage of minimal logging. Key thing there, difference between 2005 and 2008 is the ability to do it when you already have data in there, where in 2005 you were limited. As we look at managing our partitions, we can make it easier to switch out partitions to archive the old data, switch in new partitions without dropping and recreating indexes. We saw an example of the backup compression, so we can save disk storage, complete backup, restore operations more effectively as we use backup compression. And then finally, we took a look at controlling the impact of multiple workloads as we take advantage of the resource governor, which is new in SQL Server 2008. So with that, I do appreciate your time for today's webcast. I do have some links out there in the Q&A, but if you have any other questions, it'd be a great time to submit that question. I'm going to go hit the Q&A area while Alex wraps up today's session and tells you about the survey. Alex, bring us home.
Thanks, Brian. If you have any questions for our presenter, go ahead and submit those now by using the Q&A pane in the lower right-hand corner of your interface, and we'll be getting those in just a minute. I would like to remind everyone that you may print a PDF of the slides by right-clicking on the slide area and selecting Print to PDF, or by clicking on the print icon in the lower right-hand of your screen. Also, watch your inbox tomorrow for an email with information about viewing this webcast on demand. The email will also include a link to a downloadable PowerPoint of today's webcast. You should all be seeing a survey now in your slide area. If you could take a moment to fill it out before you log off, we do appreciate any feedback you leave for us. All you need to do is follow the links provided to complete the evaluation. And with that, I'm going to hand the floor back over to Brian to wrap up the questions.
All right, well, we do have one question there from Kashu. However, Kashu, this is off topic from today's discussion. It's around integration services, and it looks like it's a pretty detailed question. So what I'm going to ask you to do is actually email me that question so that I can take care of that and get you pointed in the right direction. So that was a question on integration services, not really appropriate to today's discussion. But again, you do have my email. So again, that is in the Q&A log, brian.vonaxelson@microsoft.com. So Kushu, as well as anybody else that might have a question around SQL Server 2005, 2008, please feel free to email me, and we'll get you taken care of. That is the only question I see in the webcast Q&A panel. So with that, I do like to thank you for your time. We are going a little off schedule next week. We're actually making up a webcast that was delayed due to some content and travel issues with myself. So I'll be back next Tuesday to make up some of our performance troubleshooting with SQL Server 2008. So we do have a webcast next Tuesday. So take a look at that out to Microsoft.com/webcast as we continue through some of the things with 24 hours of SQL Server 2008. So with that, thank you very much. Do appreciate your time. Please take time to fill out the survey. As I always tend to tell you, we go 60 to 75 minutes, so we're right there. Give you some time back in your day-to-day, and thanks again for coming out to today's webcast.
And once again, I'd like to remind everyone to take one moment to fill out the survey prior to exiting the session room. And with that, I'd like to extend a special thanks to Bryan von Axelson for today's presentation. Thank you all for joining us today. You may now disconnect from the audio portion of today's conference.